The second video in our series set of videos looks at general results. There are some very useful general results. If you want to sum r to the 0, which is 1, so if you're wanting to sum 1 from r is 1 to n, it would, every time you put in a value, it will just be 1, so it will be 1 plus 1 plus 1 plus 1 plus 1 n times, so that will equal n. So our first general result is sigma of r equals 1 to n of 1 is just n. If you are summing the integers, so r equals 1 to n of just r, so you get 1 plus 2 plus 3 all the way up to plus n, that is a half n, n plus 1, so that's another general result. Both of these will need to be learnt because you're not given them in the formula booklet. Summing r squared, so you get 1 squared plus 2 squared plus 3 squared all the way up to n squared, has the formula 1/6 n, n plus 1 to n plus 1. So if you wanted to sum the first, say, 6 square numbers, so it'll be r equals 1 to 6, so n is 6, all you do is you put 6 in here and work it out, and that will give you what the sum would be. And then r cubed, 1 cubed plus 2 cubed plus 3 cubed plus all the way up to n cubed is a quarter n squared, n plus 1 squared. The last two, these two for r squared and r cubed, are given in the formula booklet, so you don't need to remember those. It's something to note that sigma 1 r equals 1 to n of r cubed is the same as sigma r equals 1 to n of r all squared. So if you square this, a half squared gives you the quarter, n squared is n squared, and then n plus 1 all squared is the n plus 1. So the square of this one actually gives you that one. It might be helpful if you want to remember this one, you can just square root this that's in the formula booklet to get that one. We can do some algebra with our series notation. If you were wanting to add up the numbers 50 to 100, what you could do is add the numbers 1 to 100 and then take away the numbers 1 to 49 added together, and that would leave you with 50 to 100. So that's what this notation is talking about here. So if you want r from k up to n, in order to use these formulae, you have to start with r is 1. So you can do the sum for r equals 1 to n of r, of the function, but then take away everything up to k, so everything up to k minus 1. And then that would leave you with k up to n. Also, if a and b are constant, so if you had a lots of r plus b, you can split that up. The a can come out of the sigma, so sigma a lots of sigma r equals 1 to n of r, and then the b is the same as b times 1, so you can have b lots of r equals 1 to n of 1. So for example, if you wanted to find the series r cubed plus 3r squared minus 2r plus 5 for r equals 1 to n, you can split that up into each set of terms. So it's first one r equals 1 to n sigma r cubed, then you've got plus 3 lots of r equals 1 to n of sigma r squared, then you've got minus 2 lots of r equals 1 to n of sigma r, and then plus 5 lots of r equals 1 to n of sigma of 1. And then you can just, at that point, use the general formula again to find a final answer. If for some reason you want the nth term of a series, using this principle here, the nth term just means a term in position m, and you can find that by finding the sum of the first n terms and taking away the sum of the first n minus 1 terms, because what the difference between that will just be the n. Okay, because you've added up everything from 1 up to n, and here you've added everything from 1 up to n minus 1. So by taking that one away from this one, you are just left with the nth term of the series.